To begin processing the Dosy data, first load the data into JASON. When the data are first loaded, they'll be Fourier transformed and displayed as a stack plot, as we can see here, with the lowest gradient spectrum at the bottom and the highest gradient spectrum at the top. The first thing we're going to want to do with these spectra is to ensure that they're correctly phased and that the baselines are flat and sit at the 0 point. If there are any phase distortions in the spectra, or the baselines are curved or don't sit at 0, this can negatively affect the final quality of the Dosy spectrum. Now, peak-shaped distortions and progressive phase errors are usually the result of an issue in the experiment setup, which is beyond the scope of this video. Okay, so the first thing we're going to do is to look at the phasing. So if I go over to the View tab, I can increase the vertical scale of the spectra by using either the increase by 10% step or increase by 100% step. Alternatively, I can use the click wheel and rotate the click wheel away from me to increase the vertical scale. So once you've increased the vertical scale enough to be able to see the phase of the peaks at the bottom, the next step is to begin phasing the spectra. Now, in the case of the data I have here, as I increase the vertical scale, the baselines change position, which tells me that the baselines are not exactly at 0, which is something we're going to have to address in the processing here before we get the final Dosy spectrum. So I'm going to actually just change the offset of the spectra so I can see the baseline of the first increment properly. So I can select the Move Scale Spectrum tool and just increase the offset a little bit so I can see the first increment. Okay, I'm now ready to phase the spectrum. And in the case of these data, the spectra themselves are actually quite well phased to begin with, so I don't really need to apply much of a phase correction. The data you have may be slightly different or may have worse initial phases, so I'll show the basic process here. So if I go to the phase button here, I can go into interactive phasing mode. So I'm going to move the pivot point to one side of the spectrum and then apply a small 0 order phase correction, followed by a first order phase correction. Once the phasing is okay, just click the finish button on the phase mode pop-up. Okay, now we've phased the spectra properly, the next step is to apply some form of baseline correction. So again, I'm going to increase the vertical scale so I can see the baselines nice and clearly. Now, as you can see here, as I'm increasing the vertical scale, the position of the baseline is changing, which tells me that these baselines are not exactly at 0. That aside, these baselines are actually quite flat. You may find with your data that there's more curvature in the baselines. In this case, a simple drift correction is probably all I need to apply here to change the position of the baselines. If your baselines are curved, you may well need to apply a polynomial baseline correction. Now I can do either of these steps in the Process tab. So if I go over to the Process tab, I will see the process list for the Dosy data displayed here. If I want to apply a drift correction, I can just go to the drift correction option, check the box, and click apply. If I increase the vertical scale again, can see that now as I increase the vertical scale, the baselines don't change position. If the baselines were more curved, I would instead use a polynomial baseline correction. So again, just check the box. If you open the drop-down window, you can see the options for the baseline correction. Typically, a third or a fourth order polynomial baseline correction is all that's really needed here. So I'll just apply a fourth order polynomial baseline correction. I'll go back to the View tab, increase the vertical scale again. And again, we can see that the baselines are nice and flat and that they sit at the 0 point because they don't change position as I increase the vertical scale. Next, let's apply some form of apodization. So let's go to the Process tab, and we can see in the Process list, the first step is apodization. So if we open the apodization options by clicking the down arrow on the right-hand side, we can now see the different apodization options. With Dosy, Gaussian broadening can be better than the more usual Lorentzian line broadening because it helps to reduce the width of the peak skirts, which helps in turn to minimize crosstalk between neighboring peaks. So what I'm going to do here is disable the exponential or Lorentzian broadening and trapezoid and instead apply some Gaussian broadening. Now, the optimum amount of Gaussian broadening is very much a case of trial and error and will depend on the type of data that you have, but I'm just going to try the default 0.3 Hertz Gaussian broadening to begin with. So once I've selected Gaussian broadening, just click the apply button and that will re-Fourier transform the data with the Gaussian broadening.